Hello everyone. Today I will be showing you how to create a very simple save manager that you can use for your projects. This save manager can easily be reused for other projects, as you can just copy the source and add it as an autoload, and it will be working in your new project. To demonstrate how to do this, I've created this example project here. When I run it, I can click the left mouse button to add icons, and I can right click the icons to remove them again. The goal of this tutorial will be to create a save manager that saves the positions of the icons and then loads them again when the project is reopened. So let's first just quickly have a look at the existing code. There are two scenes in this project. There is the icon itself, which has an area on it to detect the mouse click. This is connected via an event to the script. In the script, we have this input event, and if we right click it here, we call this method to remove the icon. And before we queue ourselves for freeing, we emit a signal. The signal up here that says that we are being removed. If you don't know how to use signals, please just check my last video where I go into detail on how to use signals. So here is the main scene. The main scene simply contains this label that tells you what to do. And then there's a script on the root node. In this script, we have an array of icons, and we have a reference to our packed scene, which we set here in the inspector. And when an input event is detected for a left button click, we call this add icon method, wherein we connect to the node removed signal of the icon, and we add the icon as a child, and then we set it at the global position. Finally, when the removed signal is received again from any of the icons, we simply remove it from the list if it exists there. Alright, now let's move to the next part where we start creating a save manager. Alright, so the first thing I'm going to do is I'm going to go into the script folder here. I'm going to add a new folder. This is just the folder structure I like to use, where I keep my scripts separated by what function they are, but of course you can arrange your scripts as you want. So I'm just going to call this save manager, and the first thing I'm going to do with the save manager is add it as an autoload. So go to script manager, save manager, click add. Don't forget to click the add button. Alright, so now that we're writing the save manager, the first thing we need to do is we want to be able to track objects that we're going to save. So let me just set that up. We will have a var here, which will be an array with the objects that we're tracking. Let's just call it objects, make it an array, and we'll start it out as an empty array. Now, let's make a method to add an object to track. So I'll just add a new function here, something like this. The object that we should track, which should be a node. And then now the first thing we want to do here is to check that this is actually an object we can save. So the idea here is that we're going to have some methods in this object that we can call to get the data that we need to save. So let's first set up some constants here with the name of these methods. So we're going to have one to get the save data. Then we're going to have one to get the name of this save data. So this name is then expected to be unique for this object, so that we can so that we don't have a collision between different data that we are saving. Right. So this is the unique identifier that you will use to get your data back after we have loaded data. Right. So let's just start to check that the object has the methods. So we can just do has method. It will check if it has the method, and then we can also check the second method. So we'll just add an and put in the second method as well, so we can guarantee that the object has both of these methods. Oops. If it have these methods, we will do, this should be called objects. Actually, just let's make it savable objects so it's a bit clearer. Savable objects, and since an array, we do push to the back the object. And then we could return true to indicate that we have added this object, and if not, we could return false. So right now we're not doing anything particular, but we can go now to our save example in the ready function, and we can type save manager, add savable object, and then solve. We are going to need to implement these two methods. So let's start with get save name. So let's just add them down here. Oops. Get save name, this should return a string, so let's just make an export variable. So let's just set a default, but then you can overwrite it in the editor. So we just return this. And secondly, we're gonna need to get the save data, which should be a dictionary. For now, we can actually write this method already because we know what we want to save. We want to save the position of these icons. We don't particularly need anything unique about this icon, we just need a position because we're just instancing the same scene over and over. Of course, if you're saving different scenes, you would need to store which scene to instance where and so on, but since for this simple example, all we need to store is the position of the icon. So let's just create a new dictionary, because that is what we are expected to return in the end. This is, yeah, let's do it this way. So we have the icons. I believe the method variable is called icons. Yes, there's an array of objects of icons that are currently active, and then we can just put this into the array. We'll do it this way. To put vectors as strings, you need to use a method called var2string. So then I can do icon global position, and then add 1. Finally return a dictionary. So what are we doing here? We're just creating a dictionary, adding all the icons. The key for each icon is just the icon and a number. And then we put the global position into this value, and we return a dictionary. Of course, you could have put another dictionary in here, for instance, that you created inside the icon, and save that. For instance, you could also make it a dictionary that contains the scene name or something like this, so that you can instance the scene directly from this dictionary in case you have multiple scenes. You can store position, rotation, whatever else you want. For now, we're just gonna store the position into this dictionary. All right, so let's. So now we have a savable object. Our example scene is being added to the save manager when it's created, and it can provide a name and the position of all the icons on request. So the next step now would be to go to the save manager and write the actual method to save this to the disk. So for now, I'm going to set it up so that we save when the game is quit, and we will have an autosave as well. So to save when the game is quitting, the first thing we need to do is to prevent the game from quitting right away when the user tries to quit. So to do this, you go on the tree, set auto accept quit to false, like this. Then you can write a new function that connects to notification. And then you just check if you're getting a quit notification. So depending on if you write for Android or PC, you will get a different notification, but you can just check for both notification VM and then quit request. I believe this is the one you get on Windows and Linux. And for Androids or iPhone, I believe you get the go back request like this. What should we do if we get a request to quit? We should save and we should quit the game. So, oops, there. So with this little code here, we are preventing the game from quitting when the user clicks, for instance, closes the game. And before we quit, we call the save method and then we quit. So now we actually have to write the save method. So let's go do that. We can do a little print so that we can see when we save. Yeah, let's just do print save for now. We will write this in a moment. Before that, I'm gonna add one more way to save, and I'm gonna add a autosave timer. So let's add a timer here. Just set it to null for the start, and then maybe add some constants. So we could have a const. So is it enabled, and then how often? So let's just set it to 5 seconds for now. Of course, this stuff you could pull out of some configuration or something, but I'm just doing this as an example. So the next thing I want to do is create the autosave timer. So I'll write here init, for instance, init autosave, and then I will add just add a comment on this one as well. Check for game exit, and so how do we init the autosave timer? Well, we simply need to create a timer and add it to the tree and start it. So autosave timer equals a new timer. Well, actually we need to also check if we should autosave. So if autosave is enabled, then we do this. Wait time is the autosave interval. And then we need to connect to it, to the timeout signal. And we want to connect to the save method. Right? So then finally we add then we add the autosave timer as a child, and then we can start it. Right. So now we have two methods of saving the game. The first one is that we are disabling the quit when you press the cross. So if I start it and I press the cross to close the game, it actually doesn't work right now. So why is this not working? Let's debug this, and yeah, that should be an OR, right? Now, if I press the cross, you will see it write save to the console because we're calling this save method. Also, if I start the game and just wait for 5 seconds, the autosave timer should be triggering and we should be seeing save. Yeah, there it is. Save has been written to the console. So now we're calling this save method both when we're closing the game and whenever the timer times out. So the next step now will be to actually implement this save method. So now to implement the save method. What we want to do here is to grab every object in the savable objects here, call the save method that we set up earlier that it has to have, the save data and the save name, collect the data that is coming in the form of a dictionary, and then write this all to the disk. So let's start simply by looping through the objects. So load in savable objects, and since we know that we're going to be loading from the disk as well, we will eventually be loading into a dictionary. So let me just create a dictionary to hold the loaded data as well. So loaded data dictionary, and let's just make this a dictionary. So the idea for this dictionary is that the key equals the get save name, and the data is then the get save data, right? So then when someone asks me, or when the save example, for instance, asks for the name save example, we can just look up in this dictionary to see if we have a key called save example, and if so, we return the data. So let's write this then. So we're gonna write, so load the data. We have the node save name, was it? Let me just double check. Get save name. So then we get the name, we put it into the dictionary, and what we want to put there, get save data, right? So we're simply creating a new entry in this dictionary, or overwriting it if it exists, with the save data that we get from the node. Now I want to add one more thing to make it a bit easier on loading. I'm gonna add a constant here, save data name, for instance, save data, so that I can put the name into the dictionary itself. So I'm gonna do that here. Load the data, save. So I'm editing the dictionary now, and I'm gonna set the key I want, since it's a dictionary inside the dictionary. Save data name. So there we go. So I'm now actually putting, first I'm putting the save data dictionary that we get from here, which currently just contains the icon, since it's the only one we have. And I'm adding one more key to it right afterwards with the name save data name, which contains the name that we are saving. So now that we have updated our loaded data, the reason why we are updating the loaded data is because if some node that is contained within the loaded data is not yet loaded, but you still have the save data, you want that to be saved as well, right? So if I created a new dictionary here and just filled it with the data from the nodes I know about, and then saved it to the disk, then there's a chance that data would be lost, because there's no guarantee that, for instance, if you're saving data across multiple scenes, not every node will be loaded at the same time. So some data would then be in the loaded data that is not actually existing as a node at the moment. So this way we are just updating the loaded data with the latest state and then saving it to the disk. Right, so now let's write a save to file method. So I'm just gonna go here, gonna call save to file, and then let's write the save to file method to file. So I'm gonna save this in a single file and save each dictionary as JSON. So we're gonna take, gonna create a new file. We're gonna open. We need a save file name, so let's just add it up here. We want to put it in the user. Yeah, save game.json, for instance, doesn't matter. So I'm gonna open this file for file write. It's capital, isn't it? Alright, so expected, what did I do here? 74.1. It's my indentation. Ah, there we go. I missed the parentheses over there. Alright, so moving on. So we have opened the file. So now we're just going to go for each key in our loaded data. And for each key, we're simply going to write out the entire line as JSON, or entire dictionary as JSON. So we just do file, store line, JSON print will convert anything you put in here to JSON. So I can do loaded data key. Now to explain this, this will just store anything you write inside it as a line in a file. This converts whatever object you have inside here to JSON. And this loaded data is a dictionary. We are here looping through all the keys, and here we are getting the data for the key. So the key would be this get save name as explained, and the data will be the get save data. So we are currently just writing it to the file, and the final thing we can do is file close, and just so that you can say display an icon on your UI or so, we're gonna go up here, we're gonna add a signal. Signal, I don't know, on game saved, for instance, and then so if you are not familiar with signals, just go watch my last video. It will explain everything you need to know about signals, and it has additional links underneath it for more information in the description of the video. Alright, so we are now emitting a signal. We could add a button that connects to it from the UI that maybe shows for a few seconds when the game is saved from the autosave. You can emit a signal at the start of this method as well and say like we are starting to save in case you have a lot of data to save. But right now the data should be written to the file on close. So let's just check this out. So here I have opened the save file that we just created. You can see it contains the icons, and then finally it contains the save data that we added with the name of this key. This file can be found on Windows, it can be found in app data, Godot, app user data, and then the game name folder. That is when you use this user info. For Linux, I am not sure, but you can easily find it in the Godot documentation if you just search for user or user directory. Alright, so then let's move on to the next part, which will be actually loading the data. Alright, so let's start by writing the loading method. So just like this. So just like we're gonna call it similar to the same method, load from file. So we need to first open the file. So let's create a new file, and then we will check if the file exists. So file exists. Save file name. So if it does not exist, then we will simply return, because there's no need to do anything if the file doesn't actually exist. If it does exist, we will start by clearing our loaded data. It's kind of unnecessary because we're most likely only gonna call this at the start, but it's good practice to do so. Then we will open the save file. As for reading, then while we are not at the end of the file, so while we will keep reading data. Right, so what do? We will simply parse it. So to do that, JSON parse to parse a string to JSON, and then to get the next line for the file, you just call getLine. So this will now be a JSON parse result inside this JR. So we can then check that this was okay. So jr.error. If that is equal to okay, it means that we parsed the line okay. So perhaps it would fail if the user has gone and edited the line or something. You could always throw an error if it fails, but I will not bother with that here. So now we're going to add it to the loaded data. So we can just take out the result is the actual put this in here. So this is the actual dictionary that we save to the file. So I can take the data, and as when before we saved it, we added this save data name, which was the key. So we just do this, take that out, and that is then equals to the data. And finally, we close the file. So this is the load method to load from disk. It checks that the file exists, and then it opens the file. And while it's not at the end of the file, it will just parse it line by line, check that it was okay, parsed okay, and then it will put the data back into the loaded data. All right. So now we will need to write a method to get the data out of this loaded data up here. This is also very simple because we have the key. So let's write a get data function. Get data. The key you want should be a string. So if loaded data has the key, so then we know that it exists in there, we return the dictionary value, and if not, we return null. And that's it. Now we can grab the data. So now we have it. Now we just need to make sure that we load the data on startup. So we just, in the ready function, we can just call load from file, and then we will be loading the data when the game starts. Let's just add a print on here. So we can add a print right at the end. Data loaded. So right now the icons will not be spawning, but you can see that some data was loaded there, and when I close it, let's see. Alright, so now that we have loaded everything from the file and we have a method to fetch this here with get data, it's time to actually respawn these icons when we restart. So to do this, we will simply go to the ready function of our main scene, where we are adding ourselves as a savable object, and we will just call a new method that we're going to write, which is called load data. So we also add this load data method there. So what do we need to do? First, we need to get the data from the save manager. So we can just do data. What was it I called the method? It was get data. Get data and save name, right? That's the name we passed on here in the get save name. So now we will have the data, or we will have null. So if data is null, then that means there was no data stored, so we're just going to return. And if we have some data, we can loop through it and create the icons. So the data is a dictionary, as we know. So we will just do this. We need to first check if the key is the save manager save data name. If it is, we just skip it. So the save manager save data name is this save data, was the one we added down here, which we need for the loading. This is only for the loading and it's added to everything. So if we try to process this here and we expect this to be some kind of position, then this would fail. So since we only have one thing in this dictionary, which is just icons with a position, we can just assume that everything else is a position of an icon. So we're gonna just do that, and we're gonna do, we made the add icon method, I believe, yes, where we just need to pass in the position. So we can just do this in one line. We need to do the reverse conversion here of this. We did what is saved. When we saved the global position, we did the var to string. So now we need to do the string to var on this data, which is data key, like this. So if everything works now, we should be loading the icons. We can remove them, can add new ones, can close, and we can restart, and the icons are there. So everything is working. So now let's add a first finish up some loose ends, and then we will add some additional features to this. As we have seen here, we are tracking the nodes. We're tracking this savable node here. We are adding it as a savable object. And then when we need to save, we are updating this internal dictionary with loaded data from the data from that node. But of course, if we have multiple scenes or these nodes that needs to be saved disappear from the tree or is removed from the tree, we would need to detect this, else we're going to get errors when we are trying to save, because the node will not exist anymore. So essentially what we want to do is we want to detect when a node is removed. We will check if it's a savable object, and if it is a savable object, we will update the loaded data with the latest state, and then we will remove it from our list of objects. So let's do that now. To detect if a node is removed, we can go to get tree and then connect, and we want to connect to the node removed signal for self, and then on node removed, for instance. So then we just have to write this method. The node removed signal has a single parameter, which is the node that is being removed. It will still exist at the time that this is called, so you can still access it. So what we can do is we can check its savable objects if it has this node. So this is a node that we have added to the savable object list. If so, we can remove it. We have to refine it as well. So we find the index of the node and then we remove it from the savable objects. My spelling isn't that great. Oh well. What else we want to do? We want to make sure we update the data for this node, like we did down here, this code here. So I'm just going to put this into a method. Update load the data, for instance, for a node, and we're just going to copy this down, and then we're going to call it here as well. There. This will update the loaded data for the node that we pass in, and then we can just reuse this code up here. So there. Now we are updating the save storage, and then we can, for instance, print removal. Then, for instance, the node.name. So I happen to know that the node is removed from a scene node is removed from the tree before an autoload. So if I close the game, this method should actually be triggered. So let's see. There we go. And of course, because I capitalized the N in name, this is not going to work. So let's try it again. And we can see that we auto-updated the save example node when we close the game. Since we are removing it from the savable objects, it doesn't really matter. We won't be doing it twice. So we won't be, when we actually call save, this node is no longer here. So it doesn't really matter if it's on close, if it's updated from the removal method or from this method, the same method that we also call on close. Right, so now let's add another feature, a feature that I actually use in quite a lot of my games, which is the ability to automatically initialize data storages from a folder. I use this technique not only for save data like this, but I also use it for other stuff where I want to create instances of nodes or collect nodes, sorry, not nodes, scenes, or collect scenes that exist in a folder. So let's just make a new call here in the ready function of the save manager, init data storages. Let's go down to under the init autosave. So what I want to do in this method is to go to a folder in the scene tree and list all the scenes within it, and then if they are savable objects, add them to the tree so that they can be accessed, so that they can be used, right? So let's do that now. So let's make a new folder here, and before I do anything else, I'm just gonna add a constant with a path. Data storage path. It's res. As you see, top level node res. If you did not know, scenes, data storages, and I add a slash at the end, just so adding a file name after it is easy. Right, so the first thing we need to do in here is to list all the files in the directory. So we need a directory there. Then we need to try to open the data storages path. If that is okay, we're gonna do stuff. What should we do? We should list all the files in the directory. It has the first parameter of this is skip navigational. If you leave this as false, you will get two files with the name dot and dot dot returned in you while you're looping over the files in the directory. I don't find them very useful, so I'm just going to skip them. So the first thing I'm going to do is get the first file. If there is no next file, it will be empty. So we can just, while file name is empty, or while it's not empty, we can keep doing this. And as soon as it's empty, we skip. The first thing I'm going to do, so I don't forget, is make sure I iterate to the next part of my loop. This line will be at the end, but now I don't forget to add it at the end, so I don't end up creating an infinite loop. So I know that the file name should be a scene because I will only create scenes inside the data storage folder. So it's a packed scene, so I will go to the resource loader and load it. It's in the data storages path plus file name. This is why I added the slash at the end here, so I don't have to start doing this stuff here. Just makes my life easier down here. Then I need to instance a scene like this, and then I will just try to add it as a savable object. It's a method right below this one, and as you can see, it returns a true if it was added or a false if it was not. So I can check if it was added. I want to add it as a child of myself, and if not, I will just free the instance I made like this. And the final thing we need to do is after this loop, we need to end the directory listing. So to go over what we did just now, I'm calling this method from when this same manager is created. It looks into the data storage path, so this folder. It loops through all the files in it, and it tries, or it instances it. We assume it's a scene. Then it tries to add it as a savable object, which means that it has to have these methods. And then if it was a savable object, it will add it as a child, and of course it's also added to this list. And if not, it's just freeze it. So let's just print here. Our added data storage node name, and here we can print node is not data storage. Right, so let's add a node here so that we have something. So let's just call it SettingsStorage or something. So this could be like your game settings. So let's save it in here. I'm gonna add a script. I'm not gonna put it in the folder because I assume everything in there is a scene. I'm just gonna put it in here. And let's try to run it and run the game and see what happens. Node is not a data storage. Alright, this is kind of expected because we do not have these save methods within the nodes. So let's take these methods and go in here. I can just remove everything else. Let's add them. Now let's set up a name for this thing. So we gonna add a class name first of all. SettingsStorage, and then we're gonna add a constant. Storage name, for instance, SettingsStorage, and I'm gonna return this when you ask for the name of this storage. Then what data should I put in here? Let's in the save manager we have this autosave data, so let's just take this and put that in here. So it's a var now. Sure, they can be uppercase. Let me see them a bit better. So now I need to put them into this dictionary. So I need some keys for them. So cons. So autosave enabled is, and then we need the interval. So let's put them into the dictionary, which is we simply set the key equals to the value, and then we do the same thing for the second value. Simple as that. There we go. Now we should, if we start it now, we will see data storage was added. So that means that worked. If we want to take a look at the save file, we can do so. Here is the save file, and you can see that this autosave enabled autosave interval was added to the save file. So now we need to load this stuff when we start up. So we can do that in the same way as we did in the save example. In the ready method, we have this load data method. So let's just put that in here, copy the code over, just straight into the ready function. Now I happen to know that there is a bug here, so let's just go fix that. I need to make sure I load from the file before I init the data storages, else I of course cannot access the data. And since I'm also putting the autosave values now into the data storage, I will have to load the set up the autosave after I load the data storages, else I cannot access these values. So we need the storage, which is named, its name is here. If it's null, we don't need to do anything. We have our default settings here. And if it is not null, we can simply do the inverse of what we did here. So this thing is called data, and there. So now we're loading the autosave interval and putting it back. Of course, you will not see anything since we aren't printing it yet, but it's being set up. So let's just put up a way to interact with this. So I'm just going to quickly go to the save example. Or wait, actually, we need one more thing because right now we are creating the setting storage, but we cannot access it. So let's fix that first. Let's just go to the save manager where we are creating the data storages here. So let's keep track of them here. So let's add a new dictionary for this. We have a name for the data storage, and then we want this data storage object. So all we need to do is go here where we init them, and we're going to add the data storage name, which we have here somewhere. Sorry, my brain. Yeah, of course we do. It's on the node. My brain just short circuited there. We have this get save name method. So let's just add that in node dot get save name, and then we set a node in there. So then we have a reference to the data storage, and we just need a method to get it. So the storage, get data storage with the key, or we can call it the name, doesn't really matter. We will essentially be doing the same as we did down here. So we're just going to copy this up here, and we're just going to look through the data storage. If it has a data, let's just call it key for consistency there. So if it has a data storage of this key, then we return this key. Now we are able to access this SettingsStorage from anywhere by using this storage name constant. And since we have defined a class name here, we can access this constant from anywhere. So now let's go back to our save example and just quickly add some UI here. It will not be pretty, but it will work. So start with a toggle button, for instance, or a checkbox, that's fine. Oops. There we go. Autosave, we can just make a checkbox called autosave. And then we're gonna add a second one, which will be input, text edit, or line edit, I guess. I believe there's a line edit. Since it's a single line, we're just gonna slap it underneath the other one here. I'm not gonna make this very descriptive, and we're gonna call it line and interval. So let's go into the save example here, which is the code for the scene, and we just need to add some code here to get the settings. So let's add a new settings variable, and we can just call get data storage, and then SettingsStorage, those storage name, and we now have the data storage for the settings accessible here. Now we can fill in the values into these two text boxes, or button and text box. So init UI, for instance, add a method here. So we need a reference, so let's add some variables here. This is that's just a button, and this is a line edit. So button autosave, it's a button. Line interval is a line edit. So we can just do a get node, and then this is the button, check autosave. We can just grab it, and we do the same for this one, and we're gonna grab the line intervals. Now we have reference to them. Then we just need to do button autosave. I believe the variable is called checked, or is it toggle? Pressed is what it's called. So let's just set its pressed state. Pressed equals settings dot, what did we call these variable in the settings storage? Autosave enabled. And then we're gonna set the line interval. Is it text? Yes. Settings autosave interval. Let's test it. And we have of course, this is a float. We need to convert it to a string. So let's convert it to a string. And we have a 5, and you can see that autosave is checked. So autosave is enabled, and now we simply need to add editing to this stuff. And it's adding icons behind, which is fairly straightforward. We just have to do a callback So let's just connect the press signal here. On pressed, we just set the settings. Just copy it from up here. So we just do the inverse once again. That should allow us now to, if we start it, I uncheck it, close it, restart, and you'll see that the autosave is now disabled when I restart. If I check it again, close it, and restart, the autosave is now enabled. So let's just do the same for this text box. So we just do text change, I'm guessing. Let's just do it on text changed. So connect it, and we're just going to do the exact same thing. Just going to take this line here and do it in reverse. And then oops, does it work with a float like this? There we go. Let's try. Of course, you're going to have a problem if you enter something else than a number currently. And now you can see it's 10. So the final piece of this puzzle will be to go into the save manager. Let's remove the old constants. Let's add a new var, settings, and after we have initialized the data storages, we can access it. So we can do exactly the same thing as we do in the save example. So let's just go there and copy this line of code. We can remove the reference to the save manager since we are in the save manager. So now we have access to the settings here. So we just need to add it there, and I believe we use the interval. Yes, there. All right. So let's start it now. It doesn't. Oh. Autosave enable on base null. So this seems like it's what's called before the storage. Of course, I set the reference here. So I need to do it before I init the autosave. There we go. So if I set this to 1 now, it doesn't automatically refresh. But the next time I start the game, we should see saves being spammed every second, which we are. And if I turn off autosave and we restart the game, we will see that there's no autosaving. You could, of course, refresh, recreate the timer, start and stop it as you're toggling, change the interval, etc. live. I'm not going to do that, as that is not part of this tutorial. So the final thing we should do is fix these errors that are in the debugger. You might have noticed during the video that we started getting some errors here. They are pretty easy to fix. The first one is a parsing error for JSON. The reason we get this is that when we save the JSON file, we have one extra empty line added at the end of the file. So to fix that, we simply need to check for empty lines before we parse it. So we can just do this. So if line is null or the line length is less than 2, then we continue. And it's probably not valid JSON. So we just run this again, and it's a method, I guess, not a property. So we see now that this JSON error is gone. The next error we have is this inside tree error. The reason we get this error is because we are calling get save data from the save manager on the exit tree, or when we're quitting. No, actually it's on node removed here, it's being called. The thing is that when a node is being removed, its children are removed first. So what you will see here that these children nodes are not inside the tree at this point because they have already been removed before we are collecting their data. So there's a relatively simple solution to this. So the savable sprites can simply store their position as a property. So global position, let's just set it to vector to 0 by default. And then we do make a set position. I'm trying now to not overlap with the existing methods that exist. So we set this global position to the position, and then we set global position to this. And finally, we need to now, when we are initializing these things in the save example, we are adding the icon. We simply do set G position here. And one last thing, in the save example, here we just grab the position from there. So let's try it again now. We close, we see there are no errors because we are not accessing something when it's outside of the tree. We are storing the positions in a variable which we are allowed to access even if the node is not within the tree. So that's the end of this tutorial. I hope this tutorial was useful for you. It got a bit long, but I wanted to cover this whole topic in detail. If you want, the link to my GitHub where this example is on is in the description of this video, so feel free to just go and copy the source code of the save manager and you can instantly start using it in your projects. You can also adapt it, of course. It is possible, for instance, to connect here to the node added signal and then automatically registering any node, or just calling this add savable object on any node that enters the tree. This would also work. Then you do not need to remember to register yourself like we're doing here to add the savable object. You could do it this way if you prefer, or you can keep it this way. It's really up to your project. So yeah, I hope this was useful to you, and thanks for watching.